You know, in math, we're so used to finding the answer, right? That one single number. But what if there isn't just one? What if there's this whole universe of possibilities? Well, today we're going to dive into the world of linear inequalities, which is a really cool way to describe relationships that go way beyond just a simple equals sign. Okay, so right off the bat, let's just see what we're talking about. On the left, you've got a classic equation, 3x equals 15. The only answer in the universe is 5. Simple, right? But now look to the right, at the inequation. 3x is less than 15. All of a sudden, x isn't just one number anymore. It could be 4, it could be 3, it could be negative a billion. We're talking about a whole set of solutions. And that right there is the huge difference we're going to unpack. So here's how we're going to break this down. First, we'll get a solid definition for what an inequality even is. Then, we'll learn the all-important rules of the game. After that, we'll actually jump in and start solving these things. Then, we'll figure out how to visualize our answers. And finally, we'll tie it all together with a complete example from start to finish. All right, section 1. What in the world is an inequation? It's time to go beyond that good old equals sign we all know and love.
So let's start with what we already know. An equation. It's just a statement saying two things are exactly the same. X equals 5, 3x equals 7. It's like a perfectly balanced scale. One side is exactly the same as the other.
But an inequality? Well, that's all about imbalance. It's a statement that tells us one thing is not equal to the other. It's either heavier or lighter, bigger or smaller. That scale is definitely tilted one way or the other. And the way we talk about that imbalance is with these 4 key symbols. You could almost think of them as connecting verbs. We've got is less than, is greater than, and then they're close cousins, is less than or equal to, and is greater than or equal to. These little symbols are the heart and soul of every inequality. All right, let's get into section 2, the rules of the game. Because if you want to solve these puzzles, you've got to know the properties of inequality. And I've got some good news for you. If you already know how to solve basic equations, you're going to feel right at home here. Most of the time, the logic is going to feel exactly the same, but there is one huge, game-changing exception. So first up, adding and subtracting. No drama here. Just like with an equation, you can add or subtract the same number from both sides and the relationship stays true. Think about it. 8 is greater than 5. If you add, say, 13 to both sides, that's not going to change anything, right? The sign stays the same. And it's the same story when you're multiplying or dividing by a positive number. If 12 is greater than 7 and you multiply both sides by 6, the left side is still going to be bigger. The sign stays put. Easy enough, right? So far, so good. But you're going to want to pay close attention to this next part. Because this next rule, this is the one. This is the one you absolutely, positively cannot forget. It's where inequations really show their unique personality. Seriously, this changes the whole game. Okay, here it is, the big one. If you multiply or divide both sides of an inequality by a negative number, you have to flip the inequality sign. It's not optional. Look here, 15 is greater than 9, but when you multiply by -4, suddenly -60 is less than -36. See how it flipped? That's the key. Okay, now that we've got the rules down, especially the big one, we can get to the fun part. Section 3, solving the puzzle. Let's find that whole solution set for x. Here's the basic strategy, your step-by-step guide. First, clean things up. Simplify both sides if you can. Then, herd all your variables to one side and all your plain numbers to the other. Next, get x all by itself. And step 5, the most important one, don't you forget that sign flip rule. Okay, let's actually do one of these. We've got 30 minus 4 times the quantity 2x minus 1 is less than 30. Our first step is to simplify. So we're going to distribute that -4 into the parentheses. Okay, so once you do that, you're left with 34 minus 8x is less than 30. Our next move is to get that x term all by itself, so we'll subtract 34 from both sides to start clearing things out. And look where we are now. We've got -8x is less than -4. We are just one single step from our solution. But wait, you see it, right? To get x alone, we have to divide by a negative number. Ding, ding, ding. This is that moment we talked about. So we're going to divide both sides by -8. And what does that mean? It means we flip the sign. The less than becomes a greater than. And our final answer is that x is greater than 1/2. Getting that flip rate is everything.
Awesome, so we have our answer, but what does x's greater than 1/2 actually look like? How do you picture that? Let's move on to section 4 and learn how to draw our answer on a number line.
Well, there are basically two main ways we draw these solutions. If your answers are just specific whole numbers, like 1, 2, and 3, we use these thick dots, as you see on the left. But if your answer is a whole range of numbers, like all the real numbers, we use circles and a shaded line to show all the possibilities. So let's break down this visual language. It's kind of like a key for a map. A thick dot means that specific integer is part of the answer. A hollow circle means the boundary number itself is not included. That's for your greater than or less than. A filled-in circle means the boundary is included for greater than or equal to. And of course, the arrow just means the answer keeps going and going forever in that direction. Okay, we've covered a lot. We know the rules, we've solved one, we know how to draw it. Time to put it all together for one final challenge. Let's do this. All right, one last round. We've got negative 2x plus 14 is less than 6. First, subtract 14 from both sides. That gets us to negative 2x is less than negative 8. And here it is again, that critical step. We divide by negative 2, which means we must flip the sign. So our solution is x is greater than 4. To graph it, we put a hollow circle on 4, because 4 itself isn't included, and then we draw our arrow pointing to the right, covering every single number bigger than 4. And there you have it. We've cracked the code. We've seen that inequalities aren't about finding just one right answer, but a whole world of them. So that leaves me with a final question for you. Now that you know the rules, just think about the world around you. How many things can be described not with equals, but with more than, less than, at least, or at most? The possibilities are, well, infinite.